Welcome back to now lesson 8B, What's My Car Worth? And this is a great time to hit pause, read through this first page, answer question 1, and then come back and we'll work on these together. Even go ahead and underline some of the objectives. The loss of value over time is something you own, such as a car, is called depreciation. This expense is recognized by individuals and businesses for financial reporting and tax purposes. Depreciation expense generally begins when the asset is placed in service. So question number 1, why do cars lose value over time? Well, they break down, they get scratched, dented. A lot of times people prefer new cars and they're not going to pay as much for used cars and for whatever else you wrote in on this question. The objectives for this lesson are that you're going to understand that all proportional relationships are linear, but not all linear relationships are proportional. So read over that one a couple of times. All proportional relationships are linear, but not all linear relationships are proportional. That's the gist of the whole lesson. We are going to explain the difference between proportional and linear. We're going to explain, or you're going to be able to explain, why the proportionality of change in two quantities is equivalent to one quantity having a constant rate of change. And we're going to compare and contrast linear and proportional relationships. Be ready to add this information to whatever document you're using to keep up with terms and processes. Recall that two related quantities are proportional if the ratio between related pairs of values is constant. For example, in most states, the sales tax and the purchase price of a good are proportional. The ratio of the sales tax to the purchase price is going to be that constant, the sales tax rate. Proportionality is an important component of linear relationships. Some linear relationships are proportional, but some linear relationships are not proportional. If you want to highlight, underline, put stars with, let an alarm go off right here, this is where it needs to happen. If a linear relationship has 0 for the y-intercept of the graph, then the quantities and relationship are proportional. Underline it, highlight it, read it again, think on it. And in this lesson, we're going to illustrate this concept through an example involving the depreciation of a car. This is a great time to hit pause. You can do all the remaining questions 2 through 6 or do them in chunks. Like at least go ahead and complete question 2 and then come back and let's walk through it together. Let's say you bought a car for $16,500 and practice underlining, highlighting. The car is expected to last 8 years and then it can be sold for scrap at that time, 8 years later, for $500. The value at the end of the life of a car is sometimes called the salvage value or residual value. Again, good words to write down in your glossary or on flashcards or a Google document or whatever you're using. Part A, if we assume the relationship between the value of the car and the year, that this relationship is linear, how much will the value of the car depreciate each year? And explain your strategy. So do something. Grab a calculator, do something where you play around with your numbers, but ultimately you have to involve the purchase price. You have to involve the ending price, where we're starting, where we're ending up, and the difference between them is $16,000. But we're processing this across 8 years, and so that's about a depreciation of $2,000 for every 1 year. This is one way to do it, the calculation. You can do it just by subtracting, playing around with it. Whatever you chose to do, document what you did, and move on with me to question B. It asks us to complete the table of values. So at year 0, the value of the car is $16,500. But if we're going down $2,000 a year, at the end of the first year, we're at $14,500, and then $12,500, etc. And it says complete the table of values. So let's go ahead and do what we have here. And then we're at $10,500, $8,500, and $6,500. And the final number was $500. Let me double check. Right, the salvage value was $500. So part C says create a sketch of the data points on your paper. Be sure to label your graph thoroughly. Would it make sense this time to connect the points? Whereas they asked the same question dealing with the water earlier. So when we, somewhere on here, erasing that one. So when we go to create a graph, remember earlier I mentioned that if you have something that deals with time, that very likely is going to be on your x-axis. That's an independent variable. These are our years. And then from the independent variable, it's going to generate a dependent result. So I'm just going to do something real fast here. Go in 5,000s, where when we are at 0 years, we're up here at 16,500. At 1 year, we're about at 14,500. At 2 years, we're around 12,500. 3 years at 10,500. And again, I got a nice little curve going. But the idea is that it's going to be straight and it's going to be linear. And the question is it going to make sense to connect these dots? And the answer is yes this time, because at 1 1/2 years, we can go up here. If I could draw straight on this thing, we can go up here and about in this area, it's going to coordinate with a 1.5 years. Sorry, it's not straight. But the idea being, if you sell this car at any point, there is going to be a value somewhere along this line that the car is worth based on the years that you have had the car. So create a sketch, and then would it make sense to connect the dots? Yes, it makes a lot of sense to connect the dots. Again, if you haven't stopped to complete questions 3, 4, 5, and 6, this is a good time to stop, complete the questions, and then come back and work through these with me on the video. Consider all the information, consider all that we have collected on question number 2. Write an equation for the value of the car in terms of the year. So just a while ago, we had years, we had value, we had a starting point here at 16,500, and we were going down $2,000 for every 1 year. That's all we need. It already, on question B, it's asking for the slope and what does it mean in this context. And I'm already looking at the slope, so I'm going to go ahead and incorporate it. That if they are asking for an equation, the only equation you and I have talked about is y equals mx plus b. And we can fill in pieces of that equation and have a great equation for this line. Starting with the y. Instead of y, why don't we use v for the value of the car? That'll give us, I believe, more details of what's going on. The slope, that's us going down $2,000 every year. So x, that is our years. Boy, that's a little confusing. Because if we put y, we're going to think it's the y-axis. Why don't we do something like t for time? And then we're going to add in the y-intercept. So add in where we cross the y-axis, and that's at $16,500. And voila, we have an equation, and we can write it like this, or some people may not like that negative sticking out front. We could flip it around and write it like this. Both of these are great equations where you see value, a decrease, time, and a starting place. So now part B does ask us, what is the slope? Well, the slope is right here. And the slope meaning in context looks something like this. In words, we could say that for every year that you own the car, the value will decrease $2,000, or you could switch it around. Your car is going to lose $2,000 for every year that you own it. Question number 4, are the value of the car and the number of years since the car was purchased proportional? And this is the big, or one of the big pieces of the lesson talking about proportional. So there is a slightly longer way to figure this out and a quick way to figure this out. We'll go with the slightly longer way first. We're going to pick some pairs of points. I don't want to pick the first one. I'll go ahead and pick this one right here. So one of the points is 1, 14, 5, and I'll pick the one beside it, 2, 12, 5. And to find out if these are proportional, the ratios have to match. In other words, what is the ratio y to x? Well, let's take the first one. Looking at the first one, we've got 14, 5 to 1. Okay, there's a ratio, 14, 5 to 1. Well, here's this ratio, putting y over x. Y over x is going to be 12, 5 to 2. Well, we can reduce this one and get it down to something to 1, and it looks like we could do something like 6,225 to 1. Is that ratio and that ratio, are they the same? They are not. So it's not proportional. This is the longer way to do it, and the faster way is, did we pass through 0? And if we did not pass through the y-axis at 0, this is not a proportion. Done. Although the quantities are not proportional, in other words, between the value and the time, the years, question 5 asks a different question. The quantities themselves are not proportional, but are the changes in the two quantities and the ratio of that change in value to the change in years. It says to look at that. Where we're going with this is, are the changes proportional? In other words, is there a number that when you are going from here to here to here to here, is there a ratio that is the same changing from point to point? And the answer is yes. It's called slope. We are going down $2,000 for every year that you own the car. So the changes in the quantities, look at the changes in the quantities and the ratio in that change and the value of the change in the years. Are those changes proportional? Yes, the changes are proportional. The quantities themselves are not proportional when we go to look at them as a coordinate, like we looked at them, the one 1450 or 14.5 and 2 at 12.5. When we looked at them as y over x or the value over the time, this was not proportional, but the changes between them, those changes are proportional. Question number 6. Examine the proportionality of these two quantities. Which is an example of a linear equation that is also proportional? Justify your answer. Just a while ago I said there's a kind of a long way to figure this out. and there's kind of a short way. I want to look at the short way. The short way is what we talked about earlier with the objectives, and when I said make sure you underline this on the front page, there was a line that said, if a linear relationship has 0 for the y-intercept of the graph, then the quantities in the relationship are proportional. If it has 0 for the y-intercept. So when we are looking at these two linear equations, we're looking at this one and this one. You have to understand the pieces and parts. This is y equals mx plus b. So if we look at this graph, just a quick little sketch, 1, 2, 3. Whichever way this graph is going, it's going up because it's a plus 2. Where are we going through the y-axis? At 0, right here, or somewhere else? Because if the answer is somewhere else, then this is not an example of a linear equation that is also proportional. However, when you look at this next one, there's nothing listed because this graph will go through the y-axis and then up 2 over 1, up 2 over 1, up 2 over 1. In other words, it's going to be going up. And the question is, did this graph go through the y-axis at 0? If your answer is yes, then you would say, yes, this linear equation is proportional. We are finished with lesson 8b, and you need to look at your calendar to see if there are more lessons to do, and there are definitely some homework problems to do, and either watch more videos or you're done for the week. Either way, I'll be seeing you soon.